Hi, I'm Dan Zanoble, and this is my submission for ENPM690 Homework 3. The objective of this assignment was to create a containerized robot simulation capable of teleoperation and autonomous behavior using at least one sensor. I chose to make a ROS2 C++ package that simulates a custom differential drive robot using Weebots. The teleoperation node publishes to the cmdevhel topic to control the robot based on inputs from the WASD keys and the spacebar. The node also logs the current action in the terminal. Running the follower node makes the robot autonomously track and pursue an object based on color. In this case, this rubber duck that I added to the environment. The robot first turns until a yellow object is spotted, then it moves forward while turning to keep the centroid of the yellow pixels in the center of the frame. The robot stops once the duck takes up a certain percentage of the total camera view, calculated by finding the contours around the yellow pixels. This process can be visualized in RViz by subscribing to the tracked image topic. The black shape is the area within the identified contours, and the red dot is the centroid of that shape. The follower node can take command line arguments for three parameters: the robot linear speed, angular speed, and the fraction of the screen that the duck needs to take up to send the stop signal. Higher or lower speeds make the robot move faster or slower, and higher or lower stop fraction makes the robot stop closer to or further from the duck. This project was containerized using Docker Compose. The Docker container has a Ubuntu 22 distribution and contains a ROS2 workspace with the Homework 3 690 package inside. Once the package is built, the simulation can be launched and the nodes can be run as normal, although it runs much slower in the container, at least on my laptop. This slow performance could be mitigated somewhat by configuring Docker to enable GPU pass-through, increase the allowed CPU shares, or running Weebots in headless mode if only sensor data was needed. However, for the purposes of this assignment, this demonstration shows that the project has been successfully containerized.